All right, so today what we're going to talk about is one-to-one functions and their inverses. A couple of definitions here. First of all, the one-to-one function is there are no two elements that have the same image. That is, there are no two x values that have the same y value. So the easy way to do this is the horizontal line test. So just like the vertical line test, test whether or not a graph is a function, the horizontal line test whether or not a graph is a one-to-one function. So if a horizontal line hits the graph more than once, then it is not a one-to-one function. So for example, kind of a function we all know and love is a parabola, right? And so a parabola does fail the horizontal line test. So this is not a one-to-one function. It is a function, it's just not a one-to-one function. So does not being a one-to-one function mean it's bad? No. Like I said, we love parabolas and they're not one-to-one functions. But just that's something to keep in mind, okay? All right, then we're going to talk about inverse functions and the big idea of inverse functions, and you can read all this if you'd like. The big idea that I like to get across is that we switch x and y. So that's really what the inverse means. It means that x and y are kind of switched here. And so it says that the input of the original function becomes the output of the inverse function. So the input is always x, the output is y, and so those get switched whenever we're talking inverse functions. So when they give us this point here on number 1, where they say we have this point of 3, 2 as our x, y, then they ask us what is f inverse of 2. Well, f inverse of 2, normally when we have f of 2, that's saying x is 2, but now this is saying y is 2. And so if y is 2, then what's x? Well, that would mean x is 3. And then next question they have here is a little bit different. Because on the inside here we see what is f of 3, and so f of 3 we can see according to this point back here is 2, and it says 2 to the negative 1 power. So 2 to the negative 1 power we know means 1 over 2. So the thing we want to point out here is that when the negative 1 is right after the f, that is referring to inverse. But when the negative 1 is not right after the f, that means that it is an exponent. And we know a negative 1 exponent means take it down to the denominator. So important to understand that distinction, so that's why these two problems are right next to each other. All right, next up we're going to use this table, and we're going to use this right here. So important for us to remember that when we have f of 1, this is referring to an x value, and so our answer is going to be a y value, and so that's going to be this one right here, which will be 0. Now, when they say f of x equals 3, the 3 is kind of on the outside, so that's referring to a y value. And so when y is 3, we could see right here that x is 7. Next up, f inverse of 4. Now, normally when it's inside there, that's the x value, but since it's inverse, that's a y value. So I need a y value of 4, so that would be an x value of 3. Same idea here, f inverse of 9. And so that is a y value here, since we're talking inverse. So the x value would equal 8. Now, this one is really tricky here. We know that since it's an inverse, the number on the inside is referring to a y value. Even though it says x, because it's inverse, it's actually a y value. And so then by default, this one must be our x value. So I'm going to look at that point right there and say that the y value is 6. All right, so same idea here using the graph. So we just got to kind of really be careful on if we're looking for x or y. So this is a regular function, so they've given us the x. And so then the y value would be up here at a positive 3. Next one, this is going to be a y value since it's f of x equals that. So the y value of 2 is right there, and that is an x value of 2 as well. All right, f inverse of negative 2. So when it's inside of an inverse, that's referring to a y. And so the y value is -2, and so we do have that right there with an x value of -1 is our answer. F inverse of 3, so that's again referring to a y value of 3, so I do have that back up there at an x value of 3. And then F inverse of x equals 1, so since this is inside of an inverse, it is referring to a y, and so the 1 given is an x value, so at the x value of 1, the y value is -1. All right, next up we're going to find the inverse function. So for finding the inverse function here on an equation like this, there are 3 steps. So step 1 would be to switch x and y, and so that's kind of what we've been talking about here. Step 2, solve for the new y. And then step 3, call the new y f inverse of x, okay? Just kind of so it's referring to, it's an inverse of the original function. All right, so none of these really have a y, so we're really going to be switching f of x and x. And so here's what I'm going to do. I'm going to call this one x, and then 2 plus the cube root of y minus 1. So that is me switching x and y there. And now I'm going to solve for the new y. So I'm going to isolate the new y. So I'm going to subtract 2 on each side. So I get x minus 2 equals the cube root of y minus 1. And then I'm going to cube both sides. So I get x minus 2 cubed equals y minus 1. And I'm going to add 1 over here. I'm going to go ahead and put the y over on this side and call it x minus 2 to the third power plus 1. Remember, we're not allowed to send this third power in there because of the subtracting. You could write it 3 times and expand it. I don't think you need to do that. I would just leave my answer like that, but remember, I would just relabel it, and I would call it f inverse of x equals x minus 2 to the third plus 1. All right, so same idea here on number 13, so I'll start off by switching x and y. And so now I'm trying to isolate the new y. It's in the denominator, so I'm going to multiply that over here. Kind of 2 options from here. I could divide that x back over, or I could distribute this in here. I'm going to go ahead and distribute it in there. So I get xy plus 2x equals 1. So I'm going to subtract the 2x over here. So I get xy equals negative 2x plus 1. And I'm going to divide the whole thing by x. And I'm going to call this f inverse of x equals negative 2x plus 1 all over x. So that is how I would put my answer. Actually, though, there is another way to write this, and you would have gotten this if you divided this x back over on your next step, and you can still get it from here. So if I divide each of these by x individually, I would get that f inverse of x equals negative 2x over x plus 1 over x. You can kind of see if I added those together with a common denominator, I would get back to that answer. And so then you can reduce that to just say negative 2 plus 1 over x, because the x's cancel out on that first fraction. So this is another way to say the same answer. I would really accept either one of these, and I think WebAssign would as well. All right, next up, number 14 is a really tough one here. So we're going to start off, we're going to switch our x and y, of course. And you can see you can kind of anticipate what's going to make this very challenging is that we have kind of 2 different y's here. I'm going to start off by multiplying the y plus 1 over to this other side. Cancel that out. I am going to distribute the x in there, so I get xy plus x equals 2y minus 3. So I have still those 2 different y's, and they are not like terms, but what I'm going to do is I'm going to get them all on the same side. So I'm going to get everything with a y on the left side, let's say, and I'm going to get everything without a y on the right side. So this will cancel, I get xy minus 2y equals negative x minus 3. So that's always what you want to do when you when you have this where you have like two of the same variable you're trying to isolate in unlike terms, okay? So then next step is to factor the y out front, and so I'm going to GCF a y, which would give me x minus 2. And now you can see I've turned those two y's into just one y. So my last step is just to divide by x minus 2. And I can say that f inverse of x equals negative x minus 3 over x minus 2. So I'm going to put my answer like that. But I'm going to tell you here that there's always two ways to write these ones that are fractions. So I could just as easily write this one if I switch all the signs. So I'm going to make it positive x plus 3 over negative x plus 2. So you see how every single sign in a fraction gets switched. That's an equivalent answer. You would have gotten that answer if you would have isolated these y terms on the right side and the non-y terms on the left side as well. So it's good. I think WebAssign will take either one of those, but it's good for you to know that there's always two ways to write those. All right, next up here, we got a function x squared plus 4. Find the domain for which the function is 1-to-1 and decreasing. So this kind of requires some knowledge of this particular function, but we should be able to graph this. It's just a parabola that's been shifted up 4. So I'll go ahead and draw that here. So it does not have to be perfect. So we got 1, 2, 3, 4. Okay, and we want the domain for which it's decreasing, and so that would be this piece over here is decreasing as we read it left to right. So I'd say the domain that we want is from negative infinity to 0 with a bracket. Okay, so now we're going to find the inverse of f with that restricted domain, and so if I take this function and I switch x and y, so x equals y squared plus 4, and then I isolate y, so I subtract the 4 over x minus 4 equals y squared, and then we square root it. Technically, when we create that square root, we should say y equals plus or minus radical x minus 4. So that kind of gives us here radical x minus 4, we know, would look like this, and then negative radical x minus 4 would look like that. Now, to figure out which piece we want, something we should know is that inverse graphs are always reflected over the line y equals x, and that's looking like that dashed line right there. So if I reflect over that line, what piece of this graph is that going to look like? And I see that it's going to match up with this piece down there. If you kind of imagine folding a paper along that dashed line, this piece would end up right here, but this piece that I was looking up would actually end up down there. So out of the plus or minus rad x minus 4, this one is going to be the, I'm going to say this, f inverse of x equals negative rad x minus 4. The plus or minus version is not a function, so this actually makes it so I'm kind of ignoring this piece and I'm ignoring that piece. And so you can see now both of my original and inverse functions pass the vertical line test. All right, so same idea here. So I have I'll draw my graph here. It's an absolute value graph that's been shifted right 1, 2, 3. Okay. And we want the piece that is increasing, so the domain on that one is going to be bracket 3 to infinity. And so to find the inverse on this one, it's pretty tricky here, given the fact we have an absolute value. We kind of don't have a way to well, actually we do. Let me take that back. So I'm going to say x equals absolute value of y minus 3. So the way we solve these ones, if we're going to isolate y, we actually make it so x equals y minus 3, but then also negative x equals y minus 3. So our final answer is going to be one of these two when we solve for it. So this one would be y equals x plus 3 if I add that 3 over. This one would be y equals negative x plus 3. Okay, so I'm going to draw both of those, and we're going to see which one looks like it's been reflected across our kind of magic line of y equals x here. So x plus 3 would be looking like this, and negative x plus 3 would be looking like this. So that looks to me like the one that's been reflected is this blue line. You can see it's kind of lining up across that dashed pink line. And so I'm going to say that's my function right there. So f inverse of x equals x plus 3.